solids have their phenomena of having particular definite shape. When external forces are applied, they could be deformed, but not so easily. You see, whenever the external forces are applied, here when I am using the term forces, I am using deforming forces, because simply when you apply the force, a body free, if the body is free, it will be subject to acceleration. But in this very chapter, we consider the body to be at least at one part stable. Then only your force could be deforming. You must know the difference between force and deforming force. Same force become deforming when it is applied on a fixed body. If the body is freely moving or it is free to move, then the force applied will only add to its acceleration. It's not going to deform. So in this chapter, we always refer to deforming force, and I hope the idea is now clear. The same force being applied on a fixed body would be called deforming force. Solids have definite form, definite shape. To deshape, to deform them, we need some external forces named as deforming. When deforming force is applied, intermolecular forces will oppose, but because of the deforming force, suppose it dominates, then obviously the length, the volume, the shape is likely to change. Now, deforming force has done what it had to do. Now, what remains after removal of the deforming force, the body is left alone with its intermolecular forces. If the body is in a position to regain its original shape, we'll say the body is elastic. If the body is not in a position to regain its original shape, we'll say the body is plastic. But actually, these two are the extremities. Perfectly elastic means the body completely regains its shapes after removal of deforming forces, and perfectly plastic means not even a 0.01% is the restoration. What we observe in practical or daily life, the things are in between, they show rather mixed behavior. But in public, you see, there is a myth, there is a long misconception regarding this elastic nature. You see somebody displaying various poses of yoga in TV screen, then you say his body is more elastic. Actually, you go to some footwear shop and just wait for few minutes over there, you will see some literate class comes over there and say they'll take the strip of the footwear, the sandal, shoes, and they'll pull like this and say, I want some more elastic strip. They have the idea if it is more pulled, it is more elastic. The fact is quite reverse. If it is resisting more, then obviously it will be stretched less. If something is stretched less, it's more elastic. Suppose you are exposed to two wrestlers and both are stretching their hand horizontally like this. They offer you to go and disturb their hand, rather fold their hands. You go to one approach and just soon as you touch, the hand is folded. You go to the other one, you try, you hammer, you jerk, you even hang. But his hand, the hand of the wrestler remains horizontal. He is more elastic. Remember, one who was deformed immediately or folded immediately, he is less elastic. So now idea should be clear. The body which is resisting more, which is opposing more the changes, that body is called more elastic. We'll come across various constants, elastic constants in another steps, that is Young's modulus, bulk modulus, shear modulus. Even we'll come across Poisson's ratio in next episodes. But here I have given the relation between them, y equal to 2 eta 1 plus sigma and 3k. K is here bulk modulus, within bracket it is 1 minus 2 sigma. One more relation is very prominent between the these constant, that is 9 upon y, 1 upon b plus 3 upon eta. I have already told you Young's modulus y, b bulk modulus, and eta shear modulus, which is also known as modulus of rigidity.